Good morning, dear students. Today let us discuss quinoline and isoquinoline. Okay. So first let us say quinoline. Now what is the IUPAC name of quinoline? IUPAC name is 2,3-benzopyridine. Okay. Now what is the structure? Quinoline has got one benzene ring, okay, and then one pyridine ring joined at these two corners. Okay. So it has got two rings, okay, both are hexagons. Nitrogen atom is here, okay, pyridine type nitrogen, it is here, okay, with the two lone pair of electrons. All right. Now let us see the synthesis of quinoline. First one is Kropf's synthesis. Now this synthesis consists of 4 steps, okay. Quinoline is obtained by heating a mixture of aniline, glycerol and concentrated sulfuric acid. So the reactants are aniline, glycerol and concentrated sulfuric acid, okay, and the oxidizing agent is nitrobenzene, okay. Now ferrous sulfate is added to make the reaction less violent. The reaction is violent, therefore ferrous sulfate is added in order to make the reaction less violent. All right. So the reaction takes place in 4 steps. Now let us see step by step. Okay. Now what is the first step? Now in this first step, glycerol undergoes dehydration with sulfuric acid to give one acrolein. Okay. You can see the molecular formula of glycerol. Okay. It is a trihydric alcohol. Okay. You can see 3 OH groups and 2 primary alcoholic groups CH2OH, CH2H, one secondary alcoholic group CHOH. Okay, this is glycerol. Glycerol, when it is heated with sulfuric acid, dehydration takes place to give acrolein. Okay, so this is the molecular formula of acrolein. It has got double bond and then it has got RDAD group, alright, CHO group. Now what is the second step? Here in the second step, aniline adds to acrolein, okay, 1,4 addition takes place to give the product, okay, product A. You can see here aniline. What is the molecular formula of aniline? C6H5NH2 or benzene ring and then NH2. You can see here NH2 group is here, okay. It will combine with the product of first step, that is acrolein. This is acrolein, okay. Shifting up of lone pair of electrons from nitrogen to this CH2 group takes place. This pi bond gets shifted, okay, so that double bond gets shifted, okay. This becomes carbon become positive charge, therefore nitrogen attacks here and then nitrogen will get the positive charge, you can see here, okay. Then this is highly unstable, once again rearrangement takes place, okay. This bond will break, NH bond will break, one of the NH bond. So hydrogen becomes one positively charged, okay. This electrons will get shifted over to nitrogen. So O minus and H will combine to give OH group over here, okay. So that you get this product A. Alright. Now what is the third step? In the third step, ring closure takes place, okay, in the presence of constant sulfuric acid to form 1,2-dihydroquinoline. You can see here constant sulfuric acid dehydrating agent. OH and H is here, okay, benzene ring hydrogen is here, so elimination of a molecule of water taking place, okay. So this is here, water eliminated, okay. So water molecule is eliminated and this carbon atom attaches to this benzene ring over here, okay. So that ring is closed, alright, and double bond remains as this double bond remains as it is here, okay. So this is 1,2-dihydroquinoline, okay. Now what is the fourth step? In the fourth step, 1,2-dihydroquinoline undergoes oxidation with the nitrobenzene to give quinoline nitrobenzene, okay, to give quinoline, alright. So here you can see 1,2-dihydroquinoline undergoes oxidation in the presence of nitrobenzene, okay, nitrobenzene to give what? Quinoline. So quinoline is obtained and then elimination of water molecule is formed. Alright. Now nitrobenzene is itself, okay, reduced to aniline and this aniline used up in second step, okay. So nitrobenzene, whatever is left over here, it will combine with the, okay, or it will gets reduced to aniline, so that it will once again used up in the second step. Okay. So, these are the 4 steps involved in one scrap synthesis of one quinoline. Alright. Now, let us see the second method of synthesis, Friedlander's synthesis. Okay. So, in this synthesis, quinoline is obtained by condensing orthoaminobenzaldehyde with acetaldehyde, okay, in the presence of sodium hydroxide solution. You can see here orthoaminobenzaldehyde, this is benzaldehyde, CHO group, amino, ortho position, therefore orthoaminobenzaldehyde. React with acetaldehyde. What is the formula of acetaldehyde? CH3CHO. This CH3 is written here as CH and H2. Okay, CH group is written as CH and H2. So, here elimination of a molecule of water taking place, you can see here. Similarly, here elimination of water molecule, this H2 will combine with the oxygen giving 2H2. Okay, 2 molecules of water eliminated, and this nitrogen will combine here, okay, with carbon to give one quinoline. Okay. So, orthoaminobenzaldehyde reacts with acetaldehyde to give one quinoline. This method is known as the Friedlander's synthesis. Alright. Now, let us see the reactions of quinoline. First one is basic character. Now, how do you explain basic character? Quinoline is a tertiary base. Okay. Therefore, it resembles pyridine in its reactions. It has got tertiary base because nitrogen atom is present over here, that is pyridine type of ring contains nitrogen. Okay. And it resembles, therefore, it resembles pyridine in its reactions. So, it forms a quinolinium salts with inorganic acid. So, it will combine with inorganic acid like hydrochloric acid to give one quinoline hydrochloride, which is a salt. So, N plus H will combine and then Cl minus will be here. So, this is known as quinoline hydrochloride, which is the salt formed with HCl. Okay. Now, next let us say electrophilic substitution reactions. Nitrogen atom in quinoline deactivates the pyridine ring. Okay. So, hence electrophilic reagents attack the benzene ring. So, where does the electrophilic substitution takes place? At 5th and 8th positions, that too under drastic conditions. Okay. Now, what is the mechanism? The attack at positions 5 and 8, okay, that is explained on the basis of stabilities of intermediate carbocations. So, now let us compare the stabilities of intermediate carbocations resulting from attack 5, 6 and then 8 positions. Okay. So, this is the attack at 5th position. You can see here, this is the 5th position. Okay. Now, in order to have electrophilic attack, the position must be, 5th position must be negatively charged. Okay, negatively charged. Similarly, the 8th position must be negatively charged. Okay, for the 8th attack. So, when electrophile attack, shifting up of electrons taking place, pi electrons, okay, taking place throughout the ring, okay, both the rings, okay, so that you have intermediate structures, okay, 1, 2, 3, 4, 5, these are the intermediate structure, and finally elimination of H plus taking place or minus H plus to give one 5 or 5th place electrophilic substituted product. This is this product. Okay. Now, next is attack at position 8. Here also, in order to, for the attack to position 8, it should be 8th position is this position. It should be negatively charged. Then only this will come and attack. Okay. So, shifting up of electrons taking place. Okay, throughout the ring, both the rings. So, then you will get different the resonance structures. You can see here. Okay, till here you have resonance structures. Okay, and in the last step, elimination of H plus ion taking place or minus H plus to give 8th substituted, okay, electrophile substituted product. Alright. Now, next is attack at position 6. That means 6th position should be negative center. Okay, this is the 6th position. This is the 6th position. So, this must be negative center. Okay, by the shifting up of electron, so that electrophile come and attacks here. So, this also will have resonance structures 1, 2, 3, okay, 4, 5, and finally last time elimination of H plus ion taking place to give one 6th substituted product. Okay. So, electrophilic attack at 5 or 8 gives a carbocation which is a resonance hybrid of 7 canonical structures. Okay. Out of these 4 structures, 1, 2 and 6, 7 have one aromatic sextet intact. Okay. And therefore, carbocation is more stable. The attack at 6th or 7th position gives a carbocation which is a resonance hybrid of only 5 canonical structures, out of which only 2 structures, that is first one and fifth one, have one aromatic sextet intact. Hence, the intermediate carbocation formed by the electrophilic attack at position 5 or 8 is preferred over 6th or 7th position. Okay. So, carbocation intermediate loses a proton, okay, that is in the last step, it will lose a proton and give the substituted product. Alright. Now let us say examples for electrophilic substitution. First one is nitration. Okay. Now quinoline reacts with fuming nitric acid and fuming sulfuric acid, okay, to give a mixture of 8 nitroquinoline and 5 nitroquinoline. Okay. So this is what nitration. Next is sulfonation. So when it is heated with fuming sulfuric acid, so this should be plus sulfuric acid, okay, fuming sulfuric acid heated, we get quinoline 8 sulfonic acid and then quinoline 5 sulfonic acid. Okay. Next is bromination. So bromination also we get 2 products, a mixture of 2 products, that is 5 bromoquinoline and then 8 bromoquinoline. Okay. Next, nucleophilic substitution. Now quinoline undergoes nucleophilic substitution preferably at 2nd and 4th positions. Okay. Now first one is Chichi-Babin reaction. What is Chichi-Babin reaction? Heating the reactant with the sodamide in the presence of liquid ammonia, that is known as Chichi-Babin reaction. Okay. So quinoline is heated with the sodamide. What is the formula of sodamide? NaNH2 in the presence of liquid ammonia. Okay. 2 amino product is obtained, that is 2 amino quinoline. So this reaction is known as Chichi-Babin reaction. Okay. Now next is hydroxylation. Now what is hydroxylation? Heated with potassium hydroxide, okay, alkali, potassium hydroxide, we get 2 hydroxyquinoline. So this is known as hydroxylation. Next is the reaction with organolithium compound. Okay. In organolithium compound, it is treated with normal butyl lithium. The formula of normal butyl lithium is here CH3, CH2, CH2, CH2 lithium. Okay. So this part is negative, this part is positive. Okay. This will combine with the quinoline to give 2 normal butyl quinoline. Okay. This is 2 normal butyl quinoline. Okay. Next is oxidation. Okay. Now in oxidation, quinoline is oxidized by alkaline potassium permanganate to give a mixture of 2,3 pyridine dicarboxylic acid, because 2 carboxy groups are here, COH, COH, okay, 2nd and 3rd position. So it is called 2,3 pyridine dicarboxylic acid. Okay. Here it should be nitrogen. Okay. Nitrogen is missing, there is a mistake over here, it should be nitrogen. So 2,3 pyridine dicarboxylic acid and then oxalic acid. Okay. Next is the reaction with the tin. Okay. Quinoline reacts with the tin, okay, in the presence of HCl to give on the 1, 2, 3, 4 tetrahydroquinoline. That means here double bond breaks. Okay. Here also double bond breaks. So then here CH2 group is formed. So CH was already there, CH here, okay, CH, whereas here it becomes CH2, CH2, CH2. Okay. And then this also bond breaks and nitrogen will acquire 1 hydrogen atom. Okay. Valency 3. So 1, 2, 3, 4. 4 places we have hydrogen. Okay. 1, 2, 3, 4 tetrahydroquinoline. Now how does it react with the platinum? Okay. Hydrogen gas is passed in the presence of platinum heated to 473 Kelvin. Okay. Quinoline reacts to give what, or undergoes hydrogens to give decahydroquinoline. That means 10 hydrogen atom adds up. Okay. 1 at nitrogen, rest all at these corners. Okay. So totally 10 hydrogen atoms add up. So all the double bond undergo cleavage. Okay. So there is no double bond in the product formed. alright. And what is the name of the product? Decahydroquinoline. Okay. Now next is isoquinoline. In isoquinoline, you can see nitrogen atom here. In quinoline, nitrogen atom at this point, okay, that means at this corner. Isoquinoline to the next carbon. Next carbon is replaced by nitrogen. Okay, so this is isoquinoline. Alright. Now let us see the synthesis of isoquinoline. Starting from cinnamaldehyde. Okay, how it is synthesized from cinnamaldehyde. What is the formula of cinnamaldehyde? Benzene ring, CH and then CHO. This is aldehyde group. Okay, aldehyde group. Reacts with hydroxylamine. What is the formula hydroxylamine? NH2OH. Okay, elimination of a molecule of water takes place. Okay, so that you get cinnamaldehyde, which is unstable. Okay, so resulting product is cinnamaldehyde, which is unstable. Therefore, immediately undergoes Beckmann rearrangement. Okay, to give this product. Okay. It undergoes Beckmann rearrangement to give this product. This on heating with phosphorus pentoxide eliminates a molecule of water. You can see here HOH eliminates a molecule of water to give what? Isoquinoline. Okay. So this synthesis is from cinnamaldehyde. Okay. Now next synthesis is Bichler-Naparlaski synthesis. Okay. Now in this synthesis, the 2-phenyl ethylamine is treated with formal chloride. Okay, and the product is heated with phosphorus pentoxide. So what you get? 3,4-dihydroisoquinoline. This on dehydrogenation by heating with palladium gives what? Isoquinoline. Okay, so first is 2-phenyl ethylamine heated with formal chloride. Okay, in the presence of base, elimination of HCl will take place to give the addition product, okay, N-formyl 2-phenyl ethylamine. Okay, this on rearrangement gives this product. Alright. So this on heating with phosphorus pentoxide eliminates a molecule of water. You can see here eliminates a molecule of water to give 3,4-dihydroxy, that is the dihydroisoquinoline. 3,4, this is 3,4-dihydroisoquinoline. This on heating with palladium dehydrogenation takes place. That means from here one hydrogen, from here one hydrogen. Okay, that means minus H2. Two hydrogen atoms combine to give hydrogen molecule, or in other words, dehydrogenation takes place to give one isoquinoline. Okay. Now next let us see the properties. Okay, first one is basic nature. Now isoquinoline is a stronger base than quinoline. Okay. It gives isoquinolinum salts with inorganic acids and quaternary salts with alkyl halides. Okay. So here is an example. So isoquinoline reacts with HCl to give isoquinoline hydrochloride. Since it is basic in nature, it will combine with the acid. Okay, to give isoquinoline hydrochloride. Alright. So this is the salt form. Then it will combine with the methyl iodide. This should be CH3I. Okay, there is a mistake over here, CH3I, not CHCI. Okay, CH3I, methyl iodide. This will combine with methyl iodide to give N-methyl isoquinolinum iodide. Okay, N to the nitrogen methyl group is attached. N becomes positive charge and I minus. So this is known as N-methyl isoquinolinum iodide. Okay. Now next is electrophilic substitution. First one is nitration. Okay. Now let us see nitration. Here also 5th and 8th position. Okay. Electrophilic substitution takes place at 5th and 8th position. Okay. So isoquinoline undergoes nitration to give 5-nitro isoquinoline and 8-nitro isoquinoline. Alright. Next, bromination. Now it reacts with bromine. Okay. Bromine to give what? 4-bromo isoquinoline. So this bromination occurs at 4th position. Okay, 4-bromo isoquinoline. Next is sulfonation. So when it is heated with sulfuric acid, okay, sulfonation takes place. Alright, sulfonation takes place to give on a mixture of isoquinoline 5 sulfonic acid and isoquinoline 8 sulfonic acid. Okay. Next is nucleophilic substitution. So nucleophilic substitution takes place at position 1. Okay, normally at position 1. So first one is Chichibabin reaction. What is Chichibabin reaction? Reactant is heated with sodamide. Okay. So isoquinoline heated sodamide. What is the formula of sodamide? NaNH2. Okay, sodamide. What you gain? 1 amino isoquinoline. So this should be NH2, not Br. Here there is a mistake. Okay, NH2 group is here, NaNH2. This NH2 group will come over here and attacks at first position. So this is 1 amino NH2 group must be here. It is not bromine. Okay, 1 amino isoquinoline. So this reaction is known as Chichibabin reaction. Okay. Next is oxidation. Now how does oxidation takes place? Isoquinoline undergoes oxidation, okay, with alkaline potassium permanganate, alright, to give phthalic acid and 3,4 pyridine dicarboxylic acid. Okay, so what is the molecular form of phthalic acid? Benzene ring and 2 carboxyl group as adjacent carbonate. We can see here phthalic acid. Okay, COH group is here, and then the carbon, adjacent carbon contains COH group. This is known as phthalic acid. Okay, phthalic acid and then 3,4 pyridine dicarboxylic acid. So this ring is pyridine ring because nitrogen atom is there in the ring. Okay, so third and fourth place dicarboxyl groups are there, COH groups are there. Therefore 3,4 pyridine dicarboxylic acid. Okay, so this is oxidation of isoquinoline. All right. Now next is reduction with the tin. Okay, so reduction takes place with the tin and HCl. Okay, isoquinoline undergoes reduction in the presence of tin and HCl to give 1, 2, 3, 4 tetrahydroisoquinoline. Okay, that means here first place hydrogen atom adds, second place hydrogen atom adds, third, fourth. Okay, therefore there is no double bond over here. Okay, double bond breaks. So 1, 2, 3, 4 tetrahydroisoquinoline. Okay, that is with the tin and HCl reduction. Alright. Next, reduction with Raney nickel or platinum. Okay, reduction with Raney nickel or platinum. Okay, so this is the reduction taking place. Okay, so decahydroisoquinoline, that means 10 hydrogen atoms add up, so that no double bonds present in the body. All the double bonds undergo cleavage or substitution at the each carbon atom taking place. Okay, even at nitrogen atom you can see this is pyridine type nitrogen atom there is hydrogen, that means all double bond undergo bond cleavage. Okay, single bond is formed with the substitution of hydrogen atom. Okay, therefore decahydroisoquinoline is obtained. Okay, so this is the product with the hydrogenation in the presence of nickel or platinum. Alright, with this chapter is over. Okay, please go through all the slides. Okay, any difficulty please contact me. When the offline classes starts, once again I will do especially the electrophilic substitution and nucleophilic different resonance structures and all. I am going to do it. Okay, once again. Alright, thank you.